Welcome, an initiative by Kikewa College of Horticulture, Nasik, from Department of Soil Science. I, the Professor Ines Gogre, will going to deliver an audio-visual learning for students on topic lipid metabolism. Most of lipids in the body stored in fat deposits as a triglycerides. In 70 kilogram man, lipid storage about 6 kilogram. In a concentrated form of energy, fat is an important source of food. What is what do you mean by lipid metabolism? It is synthesis and degradation of lipids in cell involving breakdown or storage of fats for energy and the synthesis of structural and functional lipids such as those involved in construction of cell membranes. The degradation of fatty acid proceeds stepwise by series of reactions, removes two carbon atoms at a time from the carbonyl end of carbon chain. This mechanism is known as beta-oxidation. The theory of beta-oxidation was originally proposed by scientist Noop. Beta-oxidation is catabolic process by which fatty acid molecules are broken down in a crystal in prokaryotes and in the mitochondria in eukaryotes to generate acetyl coenzyme A, which then enters the citric acid cycle with NADH and FADH2, which are coenzymes are used in the electron transport chain. It is referred as beta oxidation, means degradation of fatty acids in stepwise, because the beta carbon of fatty acid undergoes oxidation to a carbonyl group, involving degradation of fatty acids stepwise by series of reactions removes two carbon atoms at a time from the carbonyl end of carbon chain. This mechanism is known as beta oxidation. Then let's study about various steps involved in beta oxidation of fatty acids are A. Activation of fatty acids, B. Formation of unsaturated acetyl coenzyme A, then C. Formation of beta hydroxyl acetyl coenzyme A, then formation of beta ketoacetyl coenzyme A, then last step, that is E, thiolytic cleavage of acetyl coenzyme A. Then step A, activation of fatty acids. In the cytosol of the cell, long chain fatty acids are activated by ATP and coenzyme A, and the fatty acid coenzyme A is formed. The reaction in total is fatty acid plus coenzyme A, ATP to produce AMP plus PPI, under enzyme thiokinase, and magnesium as a activator produces acetyl coenzyme A. The equivalent of two molecules of ATP is used for fatty acid activation. This is step number 1. In this, activation of fatty acid by formation of a corresponding fatty acid coenzyme ester. ATP is a source of energy. The products are fatty acid coenzyme ester, AMP, and inorganic pyrophosphate. Then step B, Formation of unsaturated acetyl coenzyme A. The fatty acid acetyl coenzyme A undergoes enzyme acetyl coenzyme A dehydrogenase, which produces an alpha beta unsaturated acetyl coenzyme A. The CoA ester coenzyme A ester to form the alpha beta unsaturated acetyl coenzyme A. The enzyme involved in this reaction is FeD and copper or Fe. Formation of step number C. Formation of beta hydroxyl acetyl coenzyme A. The alpha beta unsaturated acetyl coenzyme A, which is formed in reaction, undergoes enzyme enol coenzyme A hydrolysis, that is beta hydroxyl coenzyme A, which is oxidized by NAD, produces beta hydroxyl acetyl coenzyme A. The hydration of alpha beta unsaturated acetyl coenzyme to form beta hydroxyl acetyl coenzyme A is net reaction. Then step D, that is formation of beta keto acetyl coenzyme A. The enzyme involved is hydroxylacetyl coenzyme A dehydrogenase, which is a specific for L isomer of beta hydroxyl coenzyme A. The bond between alpha and beta carbons of the beta ketoacetyl coenzyme is cleaved by silyl dehydrogenase, which produces beta ketoacetyl coenzyme A. Dehydrogenation of beta hydroxyl acetyl coenzyme A to form beta ketoacetyl coenzyme A. NAD is then hydrogen acceptor. Then step number E, that is thiolytic cleavage of acetyl coenzyme A. The beta keto acetyl coenzyme A undergoes enzyme beta keto thiolase, produces acetyl coenzyme A, and the shortened fatty acetyl coenzyme A repeats these 4 steps. Repetitions continue until all the carbons of the original fatty acetyl coenzyme A are converted to acetyl coenzyme A. The beta oxidation cycle first converts the fatty acid into 2 carbon units, acetyl coenzyme A. The TCA cycle then converts the acetyl moiety of acetyl coenzyme A to CO2 and H2O. Then energy from oxidation of fatty acids. Oxidation of a carbon 1 cycle yields 5 ATP and 8 molecules of acetate, where oxidized in TCA cycle will produce 8 into 12, 96 ATP. Total ATP is 131 and loss of 2 energy rich phosphates in activation step, hence 159 ATP net gained. This is all about lipid metabolism or beta oxidation of fatty acids. Thank you.